an ionic compound, no? Suppose this is ionic compound, na? For example, NaCl, no? All of you know this is ionic compound, no? Magnesium chloride, aluminium chloride, or magnesium oxide, no? But there exists some covalent character. That is, these are not 100% ionic. Some covalent character arises here. How this covalent character arises in an ionic compound? You know that means ionic compounds have two opposite ions, no? Positive ions, cation and anion, no? Suppose to form the ionic compound, suppose this is cation, no? Suppose this is anion. Come close to each other to form the ionic bond, no? That means the electrons, suppose the electrons, here also electrons present. The positive nucleus repel each other, no? The electrons of these electrons are attracted by this nucleus. You see, these electrons are attracted by this nucleus, no? That means repulsive and attractive force exists between each other. Itu nucleus repel kore. Itur electron repel kore, no? Itur nucleus electron attract kore. Itur nucleus electron attract kore, no? Suppose after some time the size of the anion will be like this. That means the size of the anion is distorted due to the attraction between these. Again, the case is also the where this is called polarization of anion by cation. That means when the anion and cation come closer to each other, the electron cloud of the anion come towards the cation. The attractive force, when the attractive force is more, the electrons come to it, and that means it seems to be a covalent character, covalent bond between the A and B. Suppose this is A, this is B. This is called polarization. The anion is polarized by the cation, and the cation is also polarized by the anion, but the extent of polarization of anion by the cation is more than the cation polarization by the anion. One scientist, FAJAN, give some points where the polarization is more. You remember one thing, when polarization is more, covalent character is more. As you see, polarization is related to the covalent character. If polarization is more, covalent character is more. You see, suppose NaCl, no? Then polarization is related to the covalent character. You remember one thing? When polarization is more, covalent character is more in an ionic compound. No, suppose you see this is sodium chloride, no? This is magnesium chloride. This is aluminium chloride. All these are ionic compounds. All these are, but there exists some ionic covalent character in these compounds. Like this polarization. After polarization between the cation and anion, the covalent character arises. But one scientist, FAJAN, gave some rules when the polarization is more or less. That is, when the covalent character is more in the ionic compounds. That is, their points are. Good. And how it affects on the polarization and the character of ionic compound. No? Suppose when the size of cation is small, size of the anion is bigger, then the polarization of the anion will be more and the covalent character will be more according to Fajan. Fajan gave the idea that the smaller cation and bigger anion, in case of bigger anion, the polarization will be more. As a result, the covalent character will be more. Beryllium chloride and magnesium chloride. You are asked to write which have more covalent character. No? That means both are ionic compound. You know. Both are ionic compound, but which have more covalent character? You see here, in case of beryllium, this is 31 picometer radius, atomic radius. Atomic radius is related to size. Now, it has 65 picometer. That means atomic radius is more. Now, that means atomic radius is less means small size. No? Small size. It is smaller than this. No? Than this. That means this has small size. That means when the size of the cation is small, then polarization is more. That means covalent character here will be more. No? Less, more. When the size is small, covalent character more. More polarization. Means what? More covalent character. More covalent character. That means this will be more covalent. No, covalent character is more here. But what will be in case of melting point? Melting point. You know one thing: the melting point of ionic compounds are higher than the covalent compound. No, ठीक है sir. Here this is 678. Melting point is lower. In case of beryllium compound, this is 678 means less than 985. No, this is in case of magnesium. That means here covalent character is more, so the melting point is less. Melting point is less, no? So this means you see when the size is small, polarization is more, covalent character is more, melting point is less. Because you know that for ionic compound the melting point are higher than the covalent compound. No? যেহেতু কি আছে covalent character বেশি আছে, গতিকে covalent character বেশি থাকা মানে তার melting point টো lower than the other. No? ঠিক আছে? Higher size of cation or anion, more polarization and hence more covalent character. No? Here if you compare the covalent character of these compounds of this, same compounds of this. You see here this is silicon, no? 4+. Ionic radius is R plus is 40 picometer. Here alumina 3+, 50 picometer. This is 2+, this is 67 picometer. Now that means here silicon 4+ have smaller size than this and this. Now that means I have said that according to Fajan, higher charge more polarization. Higher charge size is small and covalent character is more. When the covalent character is more, melting point is less. No? Because it will ionic character, covalent character less means ionic character more. No? So the melting point is 990. This is 330. That means increases. No? That means this is increases and this is decreases. No? That is this is 4+, 3+, 2+. If you compare the compounds of these three, you see when the charge is high, 4+. No, charge is high, higher charge, more covalent character, more polarization, less melting point. ঠিক আছে? Is larger than the covalent character or polarization is more. If you compare, suppose your cation is calcium in all these cases, no? Cation calcium 2 plus, no? In all these cases, if you are asked to write which have the more polarization, more covalent character, which have the more melting point, no? Then you compare the anion size, no? Anion, the size of this iodide is more than this, than this, than this. Now, this is the order, no? Increases. You know this, no? Fluorine, chlorine, bromine, iodine, no? The size is increases from top to bottom, no? Top to bottom. So here iodide have more size. Then this is the increasing order of size, no? This is size. If this compound, suppose the size is larger, covalent character is more, no? So here calcium iodide have more covalent character than this. This is the increasing order of covalent character. That means increasing order of polarization also, no? According to Hasan. So the melting point, ইফালৰ পৰা ইফাললৈকে melting point টো কি হ'ব? য'ত covalent character, where the covalent character is more, melting point is less. So the melting point is increases from this to this, na? And this. ठीक है सर? Here the size of anion, na? Here this is P3 minus phosphide ion. This is N3 minus. But the suppose here the size is 212 picometer. This for this is the 171 picometer. Both are anions, no? Here the size is smaller. Here size is bigger. So the covalent character here will be what? When size is bigger, no? Covalent character here will be more, huh? Then because as the size of the anion is larger, the covalent character will be more. No? Melting point will be less here. Take a look at the 1s2, 2s2, 3, 6, 1s2, 2s2, 3s2, 3p6, 3d, 10, 18, 18 is 8. Now, if we compare the ionic character or polarization in sodium chloride and cuprous chloride, in here we see that means it exists the sodium ion, it is copper ion. That is here the electron configuration is the valence electrons are 8. Here valence electrons are 18. So where the valence electron is 18 electron, they have more polarization. That means in case of this, the polarization is more because it has 18 electrons in their valence shell. It has 8 electrons in their valence shell. So CuCl have more covalent character than NaCl because here it has 8 electrons in their valence shell. It has 18 electrons in their valence shell. So it has more covalent character than the NaCl. Melting point of CuCl, cuprous chloride will be less than the melting point of NaCl. Because here covalent character and polarization is more, melting point less, covalent character